Hello everybody, and welcome to this video on an introduction into what physics is all about. Our objectives of this video is to be able to explain the difference between physics and engineering. The two are often confused. They're very related, but there are differences. Identify some of the current fields that physicists are studying and researching. List some of the topics we'll be talking about in AP Physics this year. And the most important thing is learn how to use a learning guide. This is something we're going to do for our online virtual classes. So we're going to do a practice learning guide associated with this assignment. So the dictionary definition of physics is a little abstract. It's a study of matter, energy, the interactions between them. But what does this really mean? I like to think of physics as dealing with the big questions of the universe. How do things work? The big things like how does the sun shine? What are the basic building blocks of matter? So it's really looking at big issues. There's a YouTube video, the link you can watch for a little bit further explanation there. Here's three of the biggest giants in physics, I would say. It started off with Galileo, Newton, the center guys who you're going to be spending most of this semester studying is Newton's laws on motion. And of course, everybody recognizes that guy over there, Einstein, and his theory of relativity. There are many other physicists who have contributed to this field, but Newton's probably the main guy we're going to be focusing on in your introductory physics class. So why should you take physics? Because it's the foundation of all the sciences. Chemistry, physics, and math are kind of your central subjects, and all the other sciences branch off from that. Whether you're going into a medical field, chemistry, whatever, they're all related to physics. Physics is the foundation of all the sciences, and physics and math are intimately related. They kind of, borrow off of each other there. So people always say, I'm going to be, I'm going into to be a veterinarian. Why do I need physics, or a physical therapist? Because all those other sciences kind of use physics at their foundation, at their most fundamental level. So it is an important science, and it's great science too. So here's the big question. What's the difference between physics and engineering? So a physicist wants to know how nature works. An engineer wants to know how can you apply it to a practical application. So the pure physicist really isn't concerned about how can this be used, or what good is it, or what can it be used for. They're just interested in the fundamental laws of nature. Einstein's your classic physicist. He wasn't concerned about how you could use the theory of relativity. He wanted to know how nature works. Most people take physics because they want to get a job, and that's where engineering comes in. It's taking the laws of physics and applying it to something that you can use, whether it's in the medical field or mechanical engineering or whatever. So take this bridge, for example. It follows Newton's laws, F equals ma, or the calculus version, dp over dt, and torque and static equilibrium. Those are the fundamental laws of physics. But to actually do the bridge, you'd have to be an engineer and understand tensile strength of different steels, expansion coefficients and how the steel expands when it's hot, when it's cold, and the stress loads. That's where the engineering comes in. So the foundation of building that bridge is physics. The actual doing and building of the bridge requires engineering. So that's why you need the two together there. Starting off with Galileo, his famous Leaning Tower of Pisa experiment. Nobody knows if he really did this experiment, but it was basically showing that when you remove air drag, heavy objects and light objects fall with the same rate of acceleration. Of course, Isaac Newton and his laws of gravity. You could use Newton's laws of gravity to figure out how to send a man to the moon. Newton was also one of the co-inventors of calculus, as he had questions related to physics. So like I was saying, the universal laws of gravity from Newton, you don't need the theory of relativity to send a man to the moon, okay? So it's just using laws of motion there. Here's some of the bigger projects that physicists are studying today. CERN, of course, is where a lot of the stuff is happening over in Switzerland. Basically, it's a huge atom smasher. They collide particles together. But to figure out what happens when you collide two particles together, you still follow the fundamental laws of physics that you'll be learning in this class about momentum and energy and collisions. Went the wrong way there. So that's one of the big areas. Here's another hot area of physics, quantum physics, which has been around since the turn of the century, over 100 years ago. There's Niels Bohr back in the 1920s. But it was quantum physics that led to the development of solid-state electronics, the computer chip, the semiconductor. That all came out of quantum physics. So the quantum physicist probably wasn't concerned, what can we use this for? The engineers working at Texas Instruments and Bell Labs turned it into a practical application with the computer chip and the semiconductor. Another big thing physicists are working on, dark matter, dark energy. This would be more astrophysics, the grand unified theory of combining all the forces together. String theory, you might have heard of that. GUT stands for grand unified theory, thinking that at higher temperatures and pressures and energies, all the forms of physics come together, or all the forces. Black holes, gravity waves, this is a new area, kind of a niche area of astrophysics, when black holes or neutron stars merge together, how they send ripples through space and time. And of course, quantum computing, quantum teleportation. This is something that's not science fiction. They are working on this as we speak, building quantum computers, and they're actually able to teleport, very small atomic objects from one place to another. Nothing on a large scale, but that's the thing physicists are working on today. So these are the topics we're going to cover in AP Physics 1. So your first semester will take you right about to here, and we are going to go at a super fast pace because you're going to meet every day for a little over 90 minutes. So we'll cover these first 5 chapters here. This is chapter 2. Okay, we'll be into that by the end of the week. Okay, and we'll go through these pretty fast, so kind of you want to keep up with your assignments and everything. And then second semester, hopefully by mid-October, we're back in school and we can do the energy, work, impulse, torque, rotational motion, and we end with a little bit on DC circuits and waves. So that's what we cover in first semester physics, or I should say our AP Physics 1. In a college class, that would be your first semester. Okay, if you were to take second semester physics, this would be AP Physics 2, which maybe we'll have next year. This gets more into circuits and magnetism, light and optics, nuclear physics, and quantum physics. Kind of the newer physics, 20th century physics stuff there. So that's what Physics 2 covers. And if you hear about the other class, AP Physics C, it's pretty much the same topics you guys cover, but there's a lot of calculus interwoven into the math. I'll show you some of the calculus in here, but it's not required. It's always extra credit if you can do the calculus. You do not need to be in calculus for AP Physics 1. But for AP Physics C, yes, you would need to be enrolled in calculus or through calculus to take that course. All right, when you finish this, there's a couple of questions. There's a learning guide that's under classwork in Google Classroom. Click on that. You're going to get one of these every Wednesday. All of your teachers are going to hand out a learning guide. Now, that learning guide should have all of your assignments for the week. This learning guide, I want you to turn in right away just to make sure we know how to use these, that I'm doing it right and you're doing it right. So you're going to watch the video, which you've already done, and then you're going to click the link that has the assignment in here. You can follow these steps right here on the next page. Basically, what you're going to do is answer the questions, and then once you answer those questions, you're going to put the URL right in here, okay? And then you're going to turn in that with your URL, and that's going to have your work on there, and I'm just going to check it so our next day in class we can go through and see what kind of issues anybody had. Hopefully my mailbox will be filled with everybody's learning guide from that first assignment. Okay, it should only take you a few minutes. It's just a couple of questions. Okay, so basically it just kind of highlights what I just talked about. Here are the steps on using your learning guide. I hope this works out. You want to make a copy, finish it, share the topic with me, and so on and so forth. So follow those step by step. After you finish answering those questions, then you want to post your URL right here, and you want to turn it into me. Okay, if you have any questions, please feel free to email me. I will be available during class time. Okay, so hope you have a great day, and let me know if you have any questions. So